So in today's presentation, I'll be presenting to you all the topic of why and how modeling and simulation-based marine spatial planning is extremely important for India for a sustainable governance. Now, this concept as such devised uh, is coming from an existing framework of marine spatial planning that has been existing since 1980s. So to quickly just summarize what marine spatial planning essentially is, it's an approach to manage our existing area so that multiple activities such as fishing, shipping, tourism, all the different activities that happen in a shared region can happen without clashing with each other or harming any kind of marine environment in the region. Now, as I said, marine spatial planning is not a new concept. This has been devised straight from 1980s. I believe the pilot implementation happened in the Great Barrier Reef Marine Park that's in Australia. The way it works is that because the area is extremely huge, but they also wanted to conserve the habitat, they demarcated the areas into three different zones. The first one being a general use zone for tourism and fishing, the other one being habitat protection zones where limited human activities can take place, such as diving, fishing, recreational activities, and so on. And then there are also no-take zones where human activities are completely banned to preserve the coral reefs, to preserve the marine biodiversity in the region. Now, it is important to note that the process of performing this essentially involves using static maps, identifying what are the different zones using some static data, and then demarcating them. And then obviously consulting with the stakeholders, the local community and the fishermen before going ahead and charting. Now, marine spatial planning as such is something that IMO and other agencies are trying to are making a mandate of for different countries. And this completely and this totally supports our SAGAR vision and the SDG 14 goals for economic growth, ecosystem health, and marine security. Now, although MSP has been mandated, it's not something mandated in the sense it's something that is recommended as a approach. It's not every country has been able to implement MSP to a complete as a complete framework. As you can see, India from the map, as you can see, India is still not having any kind of an official MSP. Sure, at this point of stage, the Puducherry, along with the India in collaboration with Norway as part of the Indo-Norway Integration and Ocean Initiative, have initiated steps towards implementing MSP, and the NCCR is currently working on a pilot project in Puducherry for the same. However, in this presentation, we are trying to establish how the traditional MSP frameworks that exist across the country and especially for India is not something that is efficient or it will work in the upcoming future, in the near future. Now, why this is important, I'll skip over this. I think we have spoken enough about why things are important for India. But with a vast coastline and a vast zone that we have, it is important that we make use of that. And as Arnab sir has also mentioned, that the need for indigenous capabilities is right now that we need to look at. Now, moving forward, what we saw that happened in Great Barrier Reef in 1980s, today we have come a long way now. We have a lot of decision support interfaces, as we call them, for marine spatial planning. Interfaces that showcases different areas, in a given area, what are the different kind of exclusive economic zones, what are the fishing routes, what are the marine infrastructure present in the region. And there are multiple tools that have been developed, a digital ocean platform for India, WIO Symphony for Nairobi, and so on. But all of these tools currently use static data. They use static maps to identify these things. That means that any kind of change that happens, any kind of climate change or any of those kind of impacts, those impacts are not recorded in the existing marine spatial planning tools. And now quoting, this is not something that I am saying or as an organization we are saying, quoting World Bank report from 2020, they have added the fact that in India currently there is a very fragmented and reactive approach. Multiple agencies are operating in silos with unshared data sets, leading to an uncoordinated decision. And this disjointed approach is what results in this information gap and the missed early warnings. Many of the states are still struggling to even formulate an integrated marine plan due to the limited data sharing and technical capacity that we have. So there are three aspects. There are three institutional and policy gaps that are adding to this issue of fragmentation. First is the fragmented governance. We have multiple ministries. We have Ministry of Earth Science. We have Ministry of Environment, Forest Conservation, and climate change, and so on, that manage different marine sectors with extremely poor coordination between them. So there is no central MSP authority which is leading an initiative for marine spatial planning. The second thing is lack of integration. We do not have any of the sectoral projects that we have, like ports or fisheries. They often, all of them proceed in silos, and I'll explain a few examples as we move forward. And because they proceed in silos, there is no central agencies. There's no central agencies that mandate or look at all of these aspects. And there's also weak policy framework. None of the environmental impact assessment report that we have today looks at the cumulative impact of any kind of project on the future. It essentially only considers only the site-specific impact, and that too at a limited for a limited duration of time. So the root cause is very clear. There is no mandate. The data sharing is limited, and there's no unified decision support interface that allows for marine spatial planning. Now, to bolster upon this thought, there are two examples I would like to present, and why the comment made by the World Bank is extremely important. The first one is the coastal erosion and ecological impact. In Tamil Nadu, hard structures were constructed, such as for the sea, what we call as seawalls or grounds were constructed to prevent local erosion. But without modeling the sediment flow, what essentially happened is that that fix ignored any kind of sediment dynamics and so on. And essentially because of the wave patterns are going to change, because the sediment flow is going to change, this just shifted the problem and worsened it into a nearby station rather than fixing the problem altogether. And so what we saw was the worsened erosion in nearby areas and unforeseen ecological impact. Now, had there been a modeling and simulation based spatial planning where we had assessed the cumulative impact while performing the project, this is something that could have been prevented. Another example is for stakeholder conflicts. A massive port was constructed off the coast of Kerala, which ended up completely destroying the ecosystem, completely destroying the location for the fishermen's habitat. And that what that ended up happening is many of the fishermen, roughly 56,000, ended up protesting and stopping a $900 million project. Now, this is something extremely, again, important to understand, that because the port construction only considered the infrastructure aspect of things. It did not consider how construction of port will essentially lead to marine habitat degradation. What is the cumulative impact on the other such community? That missing that angle is what causes such kind of issues to begin with. And then again, reiterating the root cause that I mentioned before, it's not that the stakeholders do not want to do it. It's just that there is no decision support interface that allows them to easily do that thing. And there's no mandate that requests them to perform a cumulative impact assessment while on an ongoing project or while performing a particular project. So what is then modeling and simulation based MSP? What we essentially present here is a kind of an additional approach, a kind of additional aspects to so what we essentially want here is adding two different aspects of the traditional MSP. What you can see in the orange zones are the traditional MSP where we have real-time or historical data streams that we have that gets embedded into decision support interface and then the stakeholder consultation and so on. What it misses is currently the simulation engine and impact analysis. There is no simulation. The modeling and simulation based MSP essentially tells that we need to model different scenarios using the current data, using the live data, and identify what are the future cases or what are the future problems that might occur with the existing ongoing project. And that is then used for multiple scenarios testing. And therefore, therefore, this MSP that we are producing is one, dynamic in nature because it will continuously adapt to the changing marine conditions, and the second, that there is a significant impact modeling that is inculcated. So every single time a project happens, we essentially look at how it will affect the ecosystem. We take feedback from the community and then we feed it back to the system, and hence looking at multiple what if scenarios. If a particular project happens, and what is the impact of it on the coastal habitat in the 10, 20 or 50 years coming forward, and therefore enabling a more of a proactive approach than a reactive approach as signaled in the report. One example now to many what we actually mean by modeling and simulation. This is one of the good examples of what we can represent, where we are representing the noise that is emitted from the ship. We are modeling and we are simulating what is the overall amount of noise that is coming live in the current day and time for a given region. By not just the shipping. So a traditional MSP will only show the shipping traffic. We go beyond that and identify what is the impact of that shipping traffic. And that's what we are trying to recommend here, that the MSP that India needs to follow is modeling and simulation based MSP. Now, in the interest of time, I'll try to rush through a bit of these. The applications in IO are huge. I think we all know that shipping noise modeling is something extremely important. Sorry. shipping noise modeling is something that is extremely important. And this is not something that I'm saying just because we can do it. This has been done in the past off the coast of Sri Lanka. They saw that the blue whales were getting the blue whales were getting eradicated in a shipping lane. They just performed a modeling, and they just identified that just by shifting the shipping route by 15 nautical miles, they can preserve the blue whales at the same time cause very less amount of disturbance to the shipping traffic as well. So such kind of simulation has shown a great amount of importance, has shown a great amount of advantage in the past, and it is something that, if inculcated in the Indian Ocean region, will also help. A few more examples, again, I'll avoid explaining through them, is habitat impact forecasting as well as climate vulnerability simulations, because both Indian Ocean region, again, is an extremely important habitat for coral reefs, and there are reports that says that it will be damaged, but more than 70% of coral reefs will be damaged by 2030. And the same goes for climate vulnerability as well. Because with increasing climate vulnerability, there is an extreme coral bleaching event that will happen in the near future. And therefore, what we say here is that for India, simulation-based MSP is not just a best practice, but it is actually a strategic necessity for four important reasons. One is extreme variability. We know that India's coast faces high variability in climate, biodiversity, and human activity, and therefore simulation-based MSP will offer a forecasting approach. Second is resource constraint. To be practically looking at it, India cannot afford a blanket deployment of expensive monitoring systems. And therefore, again, simulation-based MSP offers a cost-effective system where you deploy hydrophones not to monitor, but actually to validate. And the monitoring part is taken care by the simulation aspects. The third is the data fragmentation. Again, as explained earlier, we have multiple agencies that are using disparate data sets on their own. A simulation-based effort will mean that this simulation-based MSP will be feeding from the data collection system that we have, and that will integrate all the disparate data sets into one system where people can model different outcomes and behaviors. And of course, governance complexity. Because there are overlapping mandates, such kind of a digital data-driven model will offer that transparency and also replicability. If one agency can perform an operation in a particular project, that means that the same can be replicated by other agencies in different parts of the region. And it's extremely important, again, to reiterate what Arnab sir said, that the indigenous capabilities is again important, because even for modeling and simulation-based MSP, it needs to be tailored for Indian context. Community involvement is extremely important. So such kind of a tool will have to be translated into local languages and supported by local governments and stakeholders. So this is my last slide, coming to recommendations in terms of what we saw so far. What we essentially need is, first, we need there are three forms that I have divided them into: the legislative action, capacity building, and the technological investments that we need to make. In terms of legislative actions, we need to enact a national marine special planning bill. The reason for that is that we need a legal mandate, or we need to institutionalize MSP across multiple ministries and coastal states, so that everything is coordinated and there's no siloed implementation of marine special planning. The second thing is that MSP needs to be mandated as an extremely important aspect of environmental impact assessment, and that should also predict like long-term cumulative impacts rather than a short-term or short-sighted impact on the immediate region. It should also look at what is the impact on neighboring areas, what is the impact on other parts of the thing, and all of this will be possible if a simulation-based MSP approach is taken and a decision support tool has been implemented. The second thing is capacity building. The key idea being that one of the reason agreeably why MSP in general, let's not even talk about simulation-based MSP. MSP in general is difficult to mandate is because of the lack of capacity. We do not have skilled human resources. We do not have the institutional capacity, both in terms of infrastructure and resources, as well as in terms of knowledge, to implement such kind of broad marine special planning. So again, we need dedicated MSP cells and agencies such as NCCR and NCSM that can establish a national coastal and a marine special planning institute, which will train such kind of skilled humans. And we also need to set up an interministerial MSP committee, which can be led by central authorities such as Niti Aayog, because we need to ensure that any kind of policies that have been drafted by multiple state governments, there needs to be one nodal agency which can align all of those things. And also data sharing and making sure that things are not siloed is important, and that can be taken care by such kind of central authority. And lastly, technology investments are extremely important. While we try to prevent the cost in terms of the blanket deployment of expensive sonar, expensive hydrophones, or any other kind of monitoring systems. We do still need to invest in AI high performance computers, because this is what actually will perform those kind of simulations and analysis. And while all the countries are doing a similar thing, it is time that India catches up with that kind of digital infrastructure for supporting this. And we need a digital twin of the Indian Ocean. This is something that NOAA, an American agency, has already performed, where it is trying to create a digital twin of the ocean, where it showcases exactly what a complete digital twin, where all kind of source modeling can take place, like where are the different where are the different marine habitats, what is the depth of each water, what kind of surface profiles, what is the sediment property of the region, and so on and so forth. All of this has been there are initiatives that are driven for that, and India too needs to take that approach and enhance the existing. I know that Incois already has a platform for a similar platform, but we need to again invest more in such kind of platforms and enhance the same, which can then further support simulation-based tools such as the one that NirDhwani Technologies is creating. With that, I finish my presentation. Thank you.